Welcome to JAMB Physics class. In today's video, we are going to focus on graphical representation of linear acceleration. Now, this is one of the topics that give a lot of students headache. So, I want to take this video here to explain every single thing for you in order for you to understand this topic. And it's called velocity time graph, which is called VT graph. So now, before we start, you need to understand what's called linear acceleration. So, what is linear acceleration? Linear acceleration describes how velocity changes with time as a body moves in a straight line. I'll come back again. Linear acceleration describes how velocity changes with time as the body or the object move in a straight line. So when you talk about linear acceleration, you actually talk about what the interaction between the velocity and the time when the body undergoes linear or undergoes travel in a straight line. So to visualize this concept, like to understand this concept or to visualize this concept very well, we are going to use the velocity time graph. And the velocity time graph plots y, which is what the y-axis, which serve as what velocity to the what against the x-axis, which serve at the time. Now let me explain to you very well. So now we talk about velocity time graph. Velocity time graph. I get now in velocity time graph, what we call the y-axis. I get the y-axis is the what is the velocity. I get is what is the velocity. Now the x-axis is what is the time. I get so now that is you are plotting y against time against y. Sorry, y the y-axis against the x-axis. I get so you have this one. You have what velocity. I get velocity is equal to what meter per seconds, right? Now then here we have time. Time will be what the x-axis here, which what is time. And time is what is seconds. Do you understand? So this is called the velocity time graph. Is okay. So every velocity time graph only have every velocity time graph only have what v, which is velocity, what the vertical, right? The vertical axis. While the time is on the horizontal what axis here. Now here we have the point of intersection, which is going to be what 0. I get 0. So it starts from the initial velocity 0 here, the initial time 0 here. Do you understand? So as it moves up, the velocity what increases. As it moves to this side, the time what increases. Do you understand? I want to explain to you so that you understand very well. So please pay close attention. So let's understand what the VT graph. Now the slope and the area of the graph. Right, the slope and the area of the graph, give critical information about what the VT graph. So in the sense that in the VT graph, the two things you want to note here is what is the slope of the graph and the area of the graph. Do you understand? Now the slope, let's look at what the slope. Now slope indicates the what the acceleration. Right there. The slope always will indicate what the acceleration. Now remember, we talk about the VT graph here, we talk about slope here. Remember, slope of a graph is equal to what change in the what change in the y-axis or change in the what x-axis, right? Now remember here the y-axis is what my velocity. Here you can see what change in what in velocity about what change in time, right? If you look at acceleration here, acceleration equals to what velocity over time. So the slope of the graph is the acceleration. Do you understand? So that the slope indicates what the acceleration, right? What about the area? Area of the graph indicates the distance traveled. Right there. So slope is what is the acceleration. Area is what is distance traveled. Do you understand? So these are things you need to understand when it comes to what velocity or time graph. Two key things you want to understand here is your slope and what and area. Slope indicate what the acceleration, area indicate what the distance traveled, because these are things we have to solve calculation on that, right? So let's look at what the basic pattern in the VT graph. So this is where you need to pay close attention now. Basic pattern. So now when you look at the VT graph here, there are three main parts of the VT graph. That why we say what basic pattern in the VT graph. So the first one we want to look at is what positive slope. Straight line with what positive slope. Now, so this indicates constant what? Constant acceleration. Okay, this indicates what? Constant what? Acceleration. Now, the next thing we want to look at in this was straight line with positive graph here. The velocity increase uniformly with time. Is okay. So now when we talk about straight line with positive slope, please pay attention. There are two things here. This indicates constant acceleration. Number one. Two, the velocity increases uniformly with time. Now, let me draw this thing for you here so you understand this better. So here we have this one here. Remember, here we have the velocity here and what and the time, right? This is what meter per seconds, and this one is what seconds, right? Now, yeah, the body. Now, when it comes to straight line with positive slope here, the body always starts from rest. The body accelerates from rest. So the body always accelerates from this point 0 here, which is rest, and increase. Is okay. So now this is called straight line with what positive slope here. Now this indicates constant what acceleration, and the velocity what increases with uniform what time. No, the velocity increases uniformly with what time. So now let us say here what 5 seconds, 10 seconds, 15 seconds. Here we have what 20 what seconds, and here we have 10 meter per second. Here we have 10 meter per second. Here we have what 20 meter per second. Here we have what 30 meter per second. So as we move from here to here, what happens here? The velocity what increases. Just as the velocity increase uniformly, what the acceleration this indicates constant what acceleration. Just this is what you want to understand here. So if you look at this slope here, this slope is what positive. So we have what the positive side. Just we have what the positive side. That is what number one, straight line with what positive slope. Number two, horizontal line. This indicates no acceleration. Right there. This indicates no what acceleration because the velocity is constant. Right there. The velocity remains constant. The velocity what remains what constant here. So now, yeah, when it comes to what the horizontal line, what we want to understand here, this indicates no acceleration at all. The acceleration is 0. Now, the reason why the acceleration is 0 is because what the velocity what remain constant. Now, let me explain something for you. Remember, if you look at the slope here, here we have change in v or change in what in time, right? What does it tell you? You're going to be what the final velocity minus what initial velocity over what final time minus what initial time, right? Or you can just say time. Is okay. Now, if you check very well, if for example, yeah, I'm having this one like this, and I'm having this one like this, it's okay. Now, I'll be having what my final velocity to be what 30, my initial velocity probably, if I'm taking slope here, can be what uh like 15 year, just like what, like 15 year, right? So now there's a what change what in velocity because yeah, I can say final minus what initial, right? So I will say final time minus what initial what time is okay. Final time minus what initial time. So yeah, I can just say t2 minus what t1 is okay. So there's a change velocity here. Do you understand? So that is the that's why they say constant what acceleration. But now when it comes to the horizontal line, this indicates no acceleration and the velocity remain constant. Now let me give you an example here. Here we have this stuff here, right? This is what my velocity, this is what is my time, is okay. Now when you say that the velocity remain constant, that is there's no change, that it travel constantly. This one here is is what is increasing uniformly, right? But this one here, the velocity remains the same. Now, because the velocity remains the same, what now happens to the acceleration? There will be no acceleration. So now let us say that in this place here, you are seeing here, this horizontal line here, the final velocity equals to what is also the same as the initial velocity because there's no change what in velocity. So if you now use this one here, slope here, which is acceleration, equals to what? Change what v over what? Change what in t. What happen here? V minus u over what? T, right? Now, because there's no change, this will be what? 0. If v equals to u, what happen here? If v equals to u, you have that becomes 0, right? Now go to be 0 over what? Over the time, which is going to be 0. Just so here we have what? The horizontal line. Do you understand? Which this indicates what? This indicates no acceleration. The velocity remains constant. Understand here. Then the last one you want to look at is what? Is straight line with negative slope. Number 3, straight line with negative slope. Right there. Now here, from here, the body starts from rest. Right there, the body starts from here, rest. Here, the velocity what remains constant. Now, what about straight line with negative or slope? Now, it says that for the negative slope here, the body comes to rest. That means the body comes to rest. From here, it moves down. It's okay, it moves down. The body always comes to rest. So there's always decrease in what? In velocity. As the body comes to rest, that the velocity tends to what? To decrease, right? So now as it's decreasing, this part, remember here is what is my time, here is what is my velocity, right? So as the body comes to rest, remember here the body starts from rest. Yeah, the body starts from rest. Body starts from rest. Right there. Yeah, the body is already moving. So there's no increase in in velocity here. Yeah, the body is now the body is now coming to rest. The body is now coming to rest. Yeah, my initial velocity here is what is 0, right? What my final velocity is going to be here, right? From here now, from here the final and the initial are the same, right? But from here, since it's coming to rest, this point will now be what my initial velocity. Why should not call what my final what velocity? Just as so you only have negative acceleration. So if you should plot the graph here, you're going to be what? Now if here is 30, let's say here is 30. Now when it comes to rest, so my initial velocity is going to be what? 30. We are assuming going to be what? 30 meters per second, right? When my final velocity now, when it comes to rest, my final velocity now going to be what? V equals to what? 0, right? So here we only have what? Here we only have negative what? Acceleration. And negative acceleration is called retardation. Do you understand? When the body comes to rest. So there are two key things you want to take note of here. So there are two things you want to take note of here. One, This indicates this indicates constant. This indicates constant deceleration. Right there. This indicates constant what deceleration. Remember here, this indicates constant what acceleration, right? But here, this indicates what constant what deceleration. That's what you need to know here. 2. Velocity decreases uniformly with time. Velocity decreases uniformly with time. Is okay. This is what you want to understand here. So now, yeah, velocity increases uniformly with time. Yeah, velocity decreases uniformly with time. So these are the 3 things you need to understand here. 3 what components. If you should combine them together, yeah, that is why. If you should combine everything together, that is why you see a velocity time graph looks like this. So you always see a velocity time graph look like this. It's okay. Well, let's say a velocity time graph look like this. Here is what is the acceleration increase. Now here we have what the acceleration part. Here we have deceleration part. Here we have constant what velocity. Do you understand? So it is saying that the velocity time graph always have 3 different components. When the acceleration is increasing, when the acceleration is decreasing, when the object is moving at constant what velocity. Do you understand? There are some stuff you need to understand very well. So we are done with this part here. Let's move to the next part. What example 1 here? Uniform acceleration, right? Uniform acceleration. Now, because I really want to understand the concept here. So now look at what the scenario here. A car starts from rest and accelerates to a velocity of 20 meters per second in 5 seconds. Now in this scenario, so draw the velocity time graph here like this. It's okay. Now, here we have what our 20 meters per second, and here we have what our what 5 seconds. It's okay. Velocity against time here. So they say it accelerates to this point here. You see that? So here we have what the 20, right? And here we have what the 5 what seconds here. It's okay. This is it. So now they say it accelerates from rest. So a velocity of 20 at this time here is okay. This is what now what the constant acceleration, constant what acceleration. Please, I follow here. So if I at here is the what is the y axis, here is what is the x what axis, right? Here what is my velocity. Here's what is my time. It's okay. So how do we therefore we can get the slope and the what and the distance it travel. Do you understand? The slope is acceleration. Do you understand? While the distance is the area it covers, which I'm going to explain here. Please pay close attention here. So now look at what the slope, which is the acceleration here. Then by what change your velocity, by what change your in time. It's okay. If you check very well here, because it starts from where my initial velocity is 0 meters per second. It's okay. Then it accelerates to 20 meters per second. So which is going to be v now equals to 20 meters per second. Meter per seconds, right? Now the time the time here we have t1 is 0 seconds. My t2 is 5 seconds. 5 seconds. It's okay. So if you calculate the slope here, it's very easy. Now remember, slope equals, which is the a, equals to v minus u, or t2 minus t1, right? So if you substitute your value here, it's going to be 20 minus 0 over 5 over minus 0, right? We're going to give you 20 over 5, right? Remember, here we have this place is here we have meter per second. Here we have seconds. So when you do your calculation here, my slope, which is the acceleration, I go to what? 20 divided by 4. 20 divided by 5 is 4 meter per second what square. Is okay. That is what. This is what the uniform what acceleration. Uniform acceleration from here now. For me, I want to get the what? The distance traveled. Now, another thing I want to understand here, the distance travel is the what? Is the area itself. Right there. If you look at drawing here, you have a triangle, right? If you check it very well, this is what is a triangle. It's okay. This is what is triangle. Now, this part is what is 20 meter per seconds. Here is what 5 what seconds. It's okay. So, what is the area of a triangle? Just what is area? Because it's like the distance travel is the area. So the area of the graph is what is the distance travel. What is distance? What is the area of a triangle? Remember, area of a triangle. Area of a triangle. It's okay. Area of a triangle equals to what? Half times base times what? Height. It's okay. Half times base times height. What is the base? The base is time. What is the height? The height is what is velocity. Just that. So when you do that, you're going to be half times my base is what is 5 times my height is what is 20. Is okay. So what happened here? 2 going to 20 is what is 10. 10 times 5 you have what? 50 watts meter. So the distance travel here is called what is 50 watts meter. Just this is what you are talking about uniform what acceleration. So we have explained the what uniform acceleration. That is what example 1. Hope you are please if you are following this class here, leave a comment section that you are following this class. It's very, very important. Leave a comment section that you are following this class here. This is called uniform what acceleration. So let's move to the next one so that you understand it bit by bit. So look at what uniform deceleration. Uniform. Now we are looking at the first example is what is uniform acceleration, right? Look at what uniform deceleration here. Let's look at this scenario here. A bike is traveling at 30 meters per second and comes to rest in 6 seconds. Now, how do we get the slope and how do we get the area or the distance traveled? Do you understand? Now, the bike is traveling. So let us say here. It's okay. So now let's say yes, it's 30 meters per second. It's okay. Now the bike is traveling at this 30 meters per second here, right? And comes to rest. It's okay. That is the velocity decreases to 0. Remember, here is what? Here is 0, right? So that is it is traveling at this point here. They now come to rest at what? 6 what? Seconds. 6 seconds. Come to rest at 6 seconds here. So now let's get the slope. The slope, which is A, and the what? And the distance travel, and the distance, which is what? Which is what? Is the area. Because the area of the graph is the distance travel. I get the slope of the graph is what? Is the acceleration. Do you understand? Now let's analyze this very well. This point here is going to be what? My initial what? My initial. This is going to be what? My initial velocity here. So that my initial velocity is what? Is 30 meters per second. So right there. Now it comes to rest. This rest is not going to be what? My final velocity is going to be what? 0 because it decreases to 0. Right? Now, this is what my initial time here. My T1 here is what going to be my T2. Just that. So if you want to get the slope here, slope which is the A because of what? Change the V or change your T, right? Now going to be what? V minus what? U or T2 by T1, right? So now what is my V here? My V is because it decreases to 0 here, come to rest. So going to be what? Equals to what? 0 minus 30, right? Over my T2 is what? Is 6 minus what? 0, right? 0 minus 30 is what? Is minus 30. Remember what unit? meter per second over what? My time is 6 what seconds, right? That is it. So 6 going to 30, we have what? 5, right? So that would be what? My slope which what is a, that would be what? Minus 5 meter per second square. Now this minus here means what? It is decreasing. Right there. That is the retardation. Right there. So what is the interpretation? It means that the bike decelerates with constant acceleration of what? 5 meters per second. Now what is the interpretation here? It means that the bike decelerates uniformly with what? 5 meters per second square. So the bike decelerates. The bike decelerates uniformly with 5 meter per second square. It's okay, that is mean. That is the mean. Do you understand? So that is what the slope. Now let's look at what distance. If you check very well, this is also a triangle. This is also a triangle like this. It's also what a triangle. Right? It's also a triangle. Yeah, is what is 30 meter per second. Here is what 30 meter per second. Yeah, the time is what is 6 what seconds, right? The area here, because the triangle here, the area of a triangle is half times base times what? Height. It's okay. Half times base times height, right? So we're going to be half times my base is what is 60 times my height is what is 30. It's okay. You find out this, you cancel out this here. Here we have what? 3, right? 3 times 30 is what is 90 meter. That is the distance traveled by the bike is what is 30 what is what 90 what meter. That is it. Do you understand? That is for what? Uniform what? Deceleration. You can see how easy it is, right? So let's move to the next one. So let's look at what the third example, which is called constant velocity. Then let's look at what the scenario here. A train moves at a constant velocity of 40 meters per second for 8 seconds. So let's look at something. A train moves at constant velocity for what? 40 meters per second for 8 seconds here. So let me say that if you should look at it very well. Now here we have what? The velocity here, right? And here we have what? The time. Is okay. Now let us say here is what is 40 meters per second here, right? Now let us say here is what is 8 seconds. It's okay. Now I say that a body move at constant, it moves at constant velocity here. It's okay. There's no change velocity. So if here is what my initial, here go to be what my final here. Final is equal to what initial because it is constant here. Do you understand? So how to calculate what the acceleration here? So the slope acceleration equals to what? V minus u over what? T here is okay. T. The time is what is 8 seconds here. So if you check it very well, you go to do what? So that means my initial velocity we were u equals to what? 40 meters per second, right? Then final velocity what v is equals to what? 40 meters per second, right? Time is what? It's 8 what seconds. Time is what is 8 seconds. So my acceleration, which is what is slope, equals to what? 40 minus 40 over what? 8 equals to what? 0. If you go to be 0. What does it mean here? It means that the train maintain constant acceleration. The train maintain constant what? Acceleration. And when the train maintain constant velocity, right? And when it's constant velocity, the acceleration is what? 0. Just and the acceleration is what? 0. So now let's look at what the distance traveled. Distance, which is what is the area. There. If you look at this one here, is what is a rectangle. It's a rectangle like this. Is what is a rectangle. It's okay. Now here we have this one here, which is what is 40, right, meter per second here, and here we have the time, which is 8 what seconds. 8 seconds. So here we have 40 meter per second. Here we have what 8 seconds here. What is area of a rectangle? What is the area of a rectangle? So area of a rectangle. Area of a rectangle. It's supposed to what? Breadth times height. So which will cost? So which will call base times what? Times height. It's okay. So we're going to do what? 8 times 40. We're going to give you what? 32.0 meter. It's okay. That is the answer. Just please, if you are following this class, leave a comment section that you are following this class. If this video is helpful, leave a comment section that what this video is helpful. We are going to solve one. We have to solve one problem so that you understand this better. Just I want to solve one problem now. I want to solve one problem. Let's solve one problem. Look at what this question here. This is going to be a very nice question for you to be able to understand the concept. So now let's read the question together here. They start: a car starts from rest and accelerates uniformly until it reaches a velocity of 30 meters per second after 5 seconds. It travels uniform velocity for 15 seconds and is then brought to rest in 10 seconds with uniform retardation. Determine the following: the acceleration of the car, the retardation, the distance covered after 5 seconds, the total distance. This is what we have already done individually. But now let's understand the interpretation here. So here we have this one here. This one is the velocity time graph here. It's okay. So we are going to manage this one here. This is that a car starts from rest. Remember, this one is the rest, right? And accelerating from until it reaches 30. So here we have 30. Let us say here is what is 30 here. It's okay. 30 meter per second. It's okay. Here is 30. Sorry for the board here, right? So let's say it accelerates till reach what? Till reach what? 30, right? Till reach what? 30 after 5 seconds. So yeah, this first one here is what is 5 seconds. 5 seconds. It's okay. 5 seconds. Just that we are done with that in 5 seconds. After 5 seconds, it travels uniformly for 15 seconds. So it travels uniformly. When it gets here, it did not change. It travels uniformly for 15 seconds. So from here to here, it travels uniformly for 15 seconds. So let us say stop here for what? 15 seconds. But of course, I'm not going to put 15 here. It's okay. If you put 15 here, it does not make any sense here, because from here to here is 15. But once it gets here, we are starting from the initial point here. Just that from here to here is 5. From here to here is 15. The total is going to be what? 20. So here is what is 20 seconds. Hope you understand. Don't go put 15 here. Please don't put 15 here. Why? Because there's already 5 here. So 5 plus. So it's saying that from here to here is 5. From here to here now is now 20, which is what? 15. Right? Hope you understand. Good. So yeah, it traveled uniformly with a velocity of what? 15 seconds and brought to rest in 10 seconds. So it brought to rest, that it comes to rest. Right there. So after it brought to rest in 10 seconds. So yeah, you have to add 10 to this here to become what? 30 what seconds. That is it. So this is the graph as easy as that. Do you understand? This is the graph. So your ability to interpret the question and draw it out, making what a better physics student. Hope you understand. So now from here now let's start calculating the following here. That the acceleration of the car. Of course, my first one is my acceleration, right? Here's what is my acceleration. Here's what is my constant velocity. Here's what is my retardation. Do you understand? So now let's calculate what the acceleration here is. Very easy. If I should bring this part out, now let me just draw this part out. It's okay. Let me draw this part out like this. This is the part I'm looking for. It's okay. So from here is what is 30 meter per second, right? Here we have, remember, here we have my initial here. My initial is what is 0, right? Meter per second, right? My final is what is 30 meter per second. Hope you understand. So what my time? My time from here to here is what 5 seconds. So my t got to be what 5 what seconds. Is it clear? So my acceleration here, you can say what acceleration because what change what velocity over what the time is okay. So that got to be what 30 minus what 30 minus 0 over what 5 is okay. So got to be what 6 meter per second. 6 meter per what seconds. 6 meter per what seconds. So this first one is called 6 meter per what per seconds. It's okay. So we are done with the first one. Six meter per second square because it's acceleration, right? 6 meter per second. 6 meter per second what square, right? Yes. So let's look at the retardation. How do you calculate with the retardation? If you look at the retardation here, look at the retardation that is coming down, right? Look at the retardation here. It's okay. Look at the acceleration here. Acceleration here is the retardation here, right? So here at this top here is what is my initial, which is what is 30 meter per second, right? So when it comes to rest, my final is what is what 0 meter what per second here. My time t is what my time? My time is what is 10 seconds because from here to here now it's not for everything here. From here to here, look at it here. From here to here, so is what is 10 seconds. So my t is equal to what? My t is equal to what? 10 what seconds because they said retardation, which is only this place here. Retardation only this point here. It's okay. It's very easy. So now that is it's going to be what my deceleration here, retardation here. You can say retardation equals to what final minus initial over what t is okay. My final is what is 0. My initial is what is 30 over what 10 is okay. You got to be minus 30 over 10 divided here. So my retardation here. Retardation is what we have to ignore that minus here. We got to go 3 meter per second. That is it decreases idea. That is it. So we are done with this one here. Now the distance covered after 5 seconds. The distance covered after 5 seconds. After 5 seconds, the distance covered here after 5 seconds. So now they're asking you what is the area of this triangle here? It's okay. The area of the triangle because the distance is the area of what is area of that graph. Just and the distance is what is area of what of that graph, right? So what is the area of this one here? We are done with this one. We have done with this one here. We are looking at this one, the other one here. So to look at it here, let me just wipe this board. Remember, area of a rectangle. Area of triangle I mean equals to half times base times what height. It's okay. Half times base times height, which is equal to what? Half times my base, which is the time. It's okay, the time here from here to here, which is what is 5 times my height is what is 30. It's okay. So what will be the answer here? 30 divided by 2 times 5. Yeah, you're going to do what? 75. 75 watts meter. It's okay. You're going to do what? 75 watts meter. This time you're going to do what? 75 watts meter. As easy as that. So look at our total distance. It's okay. So total distance. Here you have distance 1, distance 2, and what distance what 3. It's okay. So I've already calculated what my distance 1 is. Okay. How do I calculate what my distance 2? How do I calculate distance 2? Remember, from here, this one is a rectangle, right? It's a rectangle, right? Rectangle like this. So here we have this rectangle here. It's okay. Now remember, the height is 30, right? Then from here to here, because I've already calculated from here, from here to here is 15. 15 what? Second is okay. So the distance you cover here is the area of the rectangle, right? What's the area of what rectangle? Base times height, right? Base times height. So area equals to what? Base times what? Height. So okay, which is going to be what? 15 times what? 30, right? 15 times 30. 15 times 30. Maybe have 450. 450 watts meter is okay. That is what my x2 is okay. Now then we now have what s3 here. This s3, this one here, s3 is okay. Here we have the what? The 30, and here we have what? The 10. It's okay because from here to here is 10, right? So it's a triangle here, just like this one you have done here. So area equals to what? Half times the base 10 times the height is 30. Is okay. So 2 I'm going to here is what? Is 5. 5 times 30, 150. Is okay. So the total distance here, so to calculate the total distance, which was the D part, the total distance, you have to what? Sum x1, this called x1, what? S3 here. So you can say, let me know why this place start. So total distance goes to x1 plus or x2 plus or x3 is okay. So my x1 is what? Is 75 plus or x2 is what? Is 450 plus x3 is what? Is 150. Sum everything together. So 75 plus 450 plus 150. So we have 675 watts meter. So we have come to the end of this class. It's okay. I know that you have benefited for this class here, and if you stay to the end of this class here, you know that you really want to succeed. I hope this video is helpful. If this video is helpful, leave a message that this video is helpful. Kindly share this video to your friends. Just and thanks for watching. See you in my next video.